So this is the third video in SC14 and it's on concentration. Again, this builds on concentration that you learned about in CC9. So we're going to have a quick recap of what we did in CC9 and then we'll move on to the new content in SC14. So when we're looking at concentration, I'm looking at the concentration of a solution. So here I've got a beaker of water. Water is a liquid, so it have the state symbol L, so it's a lowercase l. And I've got a sodium chloride here, which is a solid. And what I'm going to do is I'm going to take my sodium chloride, which is just normal table salt, and I'm going to add it to the water. And when I add it to the water, the sodium chloride will dissolve. And if it dissolves, and it's only if it dissolves, we form a solution. So instead of labeling this just as water, I'm now going to be labeling it as my NaCl solution. And because it's a solution, I'm going to be using the state symbol AQ. So I don't need to write the word water anymore because the AQ tells me that I do have water. I've got salt dissolved in water and I've got a solution. So when we're looking at concentration, we are concerned with how much salt have we dissolved in a certain volume of water. So let's just say, for example, that I had a litre of water here, and let's just say on my spoon I had 50 grams of my sodium chloride. Then the concentration of this solution would be 50 grams per litre. If I had 100 grams on my spoon, I would have 100 grams per litre. In chemistry, though, we typically don't use this unit litre. Instead, we use the unit decimeters cubed. So a litre is exactly the same as a decimeter cubed. So instead of saying 100 grams per litre, in chemistry, we would typically say 100 grams per decimeters cubed, and we use this as the unit for concentration. And I can write this two ways. I can write it as grams per decimeters cubed, or I can write it as 100 G, and I can, instead of writing that dash, I can write dm to the -3. And these two things are exactly the same. They both read as grams per decimeter cubed. It's just a different way of representing the same unit. So this we did in CC9, and we did a couple of questions on concentration. And we saw that when we were doing those questions, you were always asked to give your answer in grams per decimeters cubed, but sometimes they didn't give you the volume in decimeters cubed. Sometimes they gave you that volume in centimeters cubed. And it's really important then that you can convert from centimeters cubed into decimeters cubed, and to do that you are going to divide by 1000. So we'll have a look at some worked examples that you have in your booklet. So this is all laid out for you in the booklet. It's a repeat of what we did in CC9. To calculate the concentration, you want the mass in grams and you want to divide by the volume in decimeters cubed. This gives you the unit as grams per decimeters cubed, which is what you are always asked for. If we look at a worked example below, you've got 43 grams of sodium chloride and 500 centimeters cubed of water. They want the concentration in grams per decimeters cubed. According to my equation, whatever I've got in grams goes on the top line, so that's going to be 43 grams, and I want to divide it by the volume in decimeters cubed. I don't have a volume in decimeters cubed, I've got a volume in centimeters cubed, so the first thing I'm going to do is my unit conversion. I take my 500 centimeters cubed, I divide by 1000, I get my volume in decimeters cubed. Now I've got something in grams and I've got something in decimeters cubed, and it's just going to be the mass in grams divided by the volume in decimeters cubed. 43 divided by 0.5, that gives me my concentration, and the units are correct. Below, something similar. I'm moving from sodium chloride to lithium chloride. It doesn't affect how I'm doing this. 90 grams, so again, I've got my mass in grams straight away, but again, I've got my volume in centimeters cubed instead of decimeters. The unit conversion is the same. I divide by 1000, I get my answers in decimeters cubed, and now that I've got something in grams and something in decimeters cubed, I'm dividing to get my concentration. You'll notice here that I wrote it as grams per decimeters cubed, and then below I wrote gram dm to the -3. These two are exactly the same, and it doesn't change how you do the calculation. The calculation is still done the same way, and then even though they said what's the concentration in G dm -3, I wrote it as G dm3 because they're the same and you can use them interchangeably. So that is what we did in CC9. Now in SC14, we're going to do something really, really similar, but instead of using grams per decimeters cubed as our unit, we are going to use moles per decimeters cubed as our unit instead. So the premise is the same. You need the amount of the substance in moles, and then you need the volume that you're dissolving it in decimeters cubed. However, typically they don't give you the quantity in moles. Typically they give you the quantity as a mass instead. So you need to be able to get from mass to moles before you calculate the concentration. So again, we'll just look at an example so you can see how this is done. 15 grams of sodium chloride is dissolved in 4 decimeters cubed of water. Calculate the concentration in moles per decimeters cubed. So you don't even have to try and remember the formulas for calculating concentration because it's given to you in the unit. It tells you here mole per decimeter cubed. We know that dash line means divide. So it's whatever you've got in moles divided by whatever you've got in decimeters cubed. At the moment, you don't have anything in moles though. You do have something in decimeters cubed, but you don't have something in moles. Instead, you've got something in grams, and you need to take what you've got in grams and convert it to moles before you can calculate concentration. And we've done this millions of times already. What I need to do is divide by my formula mass. So the formula mass of NaCl, I use the big numbers from my periodic table. The mass number of sodium is 23. The mass number of chlorine is 35.5. I find my formula mass of NaCl. I then take the mass of NaCl, I divide by the formula mass, and I work out the number of moles. So it's this same equation here that we've used a million times already to convert from mass to moles. Now I've got something in moles and I've got something in decimeters cubed. To calculate the concentration, it's whatever you've got in moles divided by whatever you've got in decimeters cubed. So it's my answer divided by 4, and that is my concentration in moles per decimeters cubed. Got another example below. 50 grams of Na2O dissolved in 600 centimeters cubed, and you are asked for the concentration in moles per decimeters cubed. So again, my unit is telling me that I need something in moles and I need to divide that by something in decimeters cubed. So if I start the 50 grams of sodium oxide, I've got grams, I need moles. So I'm going to need to convert grams to moles using this equation above. Okay, so moles is mass divided by formula mass. I work out the formula mass of Na2O. Mass number of sodium is 23, so I've got 2 23s and 16 for oxygen, so it's 62. 50 grams divided by 62, this is the amount of moles. So now I've got something in moles, which is what I need. I now need something in decimeters cubed. I've currently got centimeters cubed, so I'm going to need to change it. To change centimeters cubed to decimeters cubed, I'm going to be dividing by 1000. So it's going to be 600 divided by 1000. Now I've got something. So I knew I needed something in moles and decimeters cubed. Now I've got something in moles. I've got something in decimeters cubed, and I'm just going to divide to then calculate my concentration. Again, in these questions, you can be asked to provide the concentration, and they might write, instead of writing it as moles per decimeters cubed like that, they can write it as mole dm minus 3. So instead of using that dash line, they can put a minus in front of the 3, and it means the same thing. You do it in exactly the same way. So in your practice questions, what I'm going to get you to do, the first question is a repeat of what we did in CC9. So I'm asking you to express each of the following in grams per decimeters cubed. So you need something in grams. So pay attention to 1E when I give it to you in kilograms. You need something in grams divided by something in decimeters cubed. Sometimes I give you that decimeters cubed, but other times I give you centimeters cubed, and you have to convert. In question 2, I want the answer in moles per decimeters cubed. So in the first one, I give you moles and I give you decimeters cubed. So it's just one step, 0.4 divided by 0.25. In all of the rest of them though, I'm giving you grams. So you have to go from moles to grams first, And then you also need to make sure that you've got decimeters cubed, not centimeters cubed. I've just realized now that I haven't given you the mass numbers that you're going to need to calculate moles, but you should have a periodic table. You're just going to have to look these mass numbers up on your periodic table so you can find the formula mass, and so you can do question 2. In question 3 and 4, I provided you with this formula triangle, okay? And we've had another formula triangle. We had one with mass at the top and moles and formula mass at the bottom. And now I've written this other triangle for you where I've got moles at the top and I've got concentration and volume at the bottom. And what I want you to do is I want you to use this triangle. So in question 3, I want to know how many moles, and I've given you I've given you volume and I've given you concentration. So if I use my formula triangle, with a formula triangle, I cover what I'm looking for, and what I'm left with is the formula. So I'm left with concentration times volume. So I can put a little times there. I'm left with concentration times volume, which means we concentration multiplied by volume, and I'm going to be able to find moles. You're not going to need to do any unit conversions here. You're just, oh no, wait, are you? Oh, you are. Sorry. You need to make sure that the unit that you've got for volume matches the unit for concentration. So if you've got volume in decimeters cubed, then you need to have decimeter cubed in your concentration. So the first two, they match, but in C and D, you've got centimeters cubed in your volume, so you need to convert that to decimeters cubed before you do the multiplication. The final one, I want volume. So again, you use your formula triangle, you cover volume, and you're left with moles divided by concentration. So volume equals moles divided by concentration. You have got your moles, so your moles is right here, and I'm going to be dividing by concentration. And in this case, no unit conversions are necessary. It's just going to be whatever you've got for moles divided by whatever you've got for concentration. So again, I'm going to be getting you to do these practice questions in the lesson, and you will find the answers to all of those practice questions. If you just scroll on a little bit, you'll find all of those answers are all done for you there. So please do just mark your work as you go and message me if you're having any problems.